Hey guys, today we will learn about inductor reactance at AC, alternating current. So we already learned about impedance, right? So let's move on, guys. Okay, I'll explain. So first of all, as I said, the inductor is a coil, right? So the most important is, I said, this equation. The time goes by, if the current or phi is changed, the voltage is induced, and this is inertia, right? So let's just draw pi, or it could be I current, right? Time goes by. If the current or the flux is changed, V is induced. This is Lenz's law, and this is inertia, right? So look at that. So we now know inductance, no impedance we know, right? R plus JX. This is real and this is imaginary. So it's R is actual use, right? Actual loss, like heat. But this part is, I said, not actually use, just store it and return it back. Store it, return it back. So this is in the inductor, this is store energy in the magnetic field, like this equation. You don't need to remember about this equation, okay? And it gotta be true. So it stored the energy in the magnetic field in the inductor, this. So yeah, you don't need to memorize about this. So let's move on more. So what I wanna say is, so look at that. This is a coil, and this is magnetic field is coming, right? But because of the inertia, it comes out, right? What I'm constantly, repeating again, because, someday you guys will, not just, memorize it. It gotta be just accept this situation. Yeah, so that's why. So this is because of inertia happened, right? So by the way, it interrupts. That's why we will say this part is reactance. I will say, look at that. So look at the guys. So here, the graph, you guys remember, this is a time, this is a current, right? For example, 10 ampere. So because of the inductor, it gotta be like that, right? So because of inertia, right? Okay, so what happened in the, give us a, I wanna say is, let's move on. Yeah, let's move on here. So what I wanna say is, what happened in the DC in coil or inductor? You get that? So, for example, I make a circuit. Switching, no. And this is L, I will say, okay? And DC voltage, right? And in the DC, what happened? Look at that. It's graph here, time, ampere. And also, when the switch is on and off, it also happened. But look at that. Very weird. Okay. This is continuously little bit changing. So what I want to say is from here, no change. So I will say it's a changing the current, right? The changing current. This part, I will say transient state. Okay, transient state. Otherwise, here, no change, right? Steady state section, I will say. This is steady state section. And this is a transient, state section. So it's a changing section, right? So what I want to say is, look at that. So now, as you guys know, V dt d pi time. So time goes by, it flux or I is changing. That's why it's working in even DC. So I will say is in DC part, in the transient state, it works as an inductance. You know what I mean? But otherwise, in the steady state, the coil is we say just a short. You know what I mean? Nothing. So just just a conductor. Okay, there's no changing. Look at the here. No current change, right? That's why V is 0. So which means it doesn't work. Just conductor. Okay. And what happened in the AC? Look at that. So AC is constantly changing, right? So for example, this is 60 hertz. And I will make one more. Okay. And it gotta be this color. Okay. The pulse is 2 times more, right? So it gotta be I would say 2120, double times of hertz, I would say. So you guys can see here. So what I want to say is, as you guys can see, let's go. So this one and this one. This is 1. This is 2. The red is 1, okay? So 60 hertz. And this is 120. So look at that. As you guys can see, reactance, we will say omega L. Omega is angular velocity, right? Angular velocity also changes to pi f. F is frequency. So what I want to say is if the frequency is up, the reactance is also up. It's proportional, okay? I will explain about this equation more. So what I want to say is, so let's same way thinking. So if the speed is more, we are in the car, right? Like when the car is like stop like this, inertia is really strong, right? But if we smoothly stop the car, inertia is weak, right? It's the same concept. Okay, guys? Okay, let's move on more. So what I want to say is, yeah, look at that. Yeah, how many times I wrote this equation? Look at that, guys. I have to be memorized, right? Yeah, fine. So this is Lenz's law, right? So what happened? So I will explain a little bit about the math. So we need to differentiate here, right? So simply thinking, this I said inertia, right? So if we differentiate, so what does that mean? It make it 90 degrees more lead to this. Look at that. If the cosine, it gotta be sine. You know what I mean? If we differentiate, cosine gotta be sine, right? So which means 90 degrees more lead. So that's why in this time V is lead. Yeah, V is lead and I is lag, we will say. Just a differential. For example, it's I T like this. I T I max sine omega T. We wanna do differential. So I max sine cosine omega T multiply omega. This is the result. So what I wanna say is sine to cosine, we changed it, right? So that's why I'm saying 90 degrees, lead the front part. That's why, okay? And look at that. So that's why I'm saying is this part, I will say J. J is, you guys know, here, look at that. 0, J, minus 1, minus J, right? 90 degree. right? And 180 degree here, JJ to -1, right? And one more time, minus J is here, right? That's why I'm saying. Yeah, and let's move on more. So look at that, guys. So here, so we already know about the V. Look at that. So I will, show you guys how I get it this. V, Vt, I, dt, d pi. Here, right? So for example, V phasor, J, here, L. It gotta be L here. Yeah, because L is the magnitude. So yeah, that's why I'm showing here L. This is for this is the how many tons we winding this meaning. So actually it gotta be L. It doesn't matter, okay? Now I just you guys don't need to know about this equation actually. Just I wanted to know you guys should know, yeah, to how did I get it this equation, right? So I said that this inertia I will explain j omega, right? And here is L, and it gotta be I, also same. Pi is I. So look at that. Impedance is I V, right? So if I is coming here, V is coming here, and J omega L. But look at that here. Why J omega? Yeah, what it happened here? As you guys know, now impedance is R plus JX, right? But we only have this imaginary number. So JX gotta be J omega L. So X is omega L, right? So that's why I look at it here. Here's a J minus J. So here, this part is we will say reactance because it's just J, right? So the last part is I will show you guys the page of how we do it. So as we know, we have a voltage source system, right? So it's a standard reference, right? Point. So V, and as you guys know, V, T, dt, d pi, right? D pi, or it could be I time. Minus is just inertia meaning. So now we know V is 90 degrees leading, but we want to know this is a standard, right? So V 0 here, and this is a lag, right? I is lag 90 degree, so that's why I 90 degree. Yeah, this is a pager. That's it, guys. Today's lecture. If you guys are confused, let me know about it. Okay. Actually, you don't need to too much focus on math. It's better to understand the result. Yeah, that's it, guys. See you next time, guys.